Adapt Energy dashboard, and also going to show you a lot of Sonnen information as well. I want to walk you through what each one of these pieces of data is, and this is obviously live, so we'll start with the solar. You can see that my system is generating 6,000 plus watts right now of solar. It's a beautiful sunny day. As you look down, you'll notice that my battery is 100% charged. Now that happened approximately 1:30 today. It is now 3:20, and my battery has been charged at 100%. So you'll notice there's no solar actually feeding into the battery because the battery is fully charged. However, what the solar is doing is powering the home's current consumption. Current consumption is floating between 1,700 to 2,000 watts, and then the rest is feeding the grid because my home is only using very little actually power right now. No air conditioners are on. It's pretty much just lights and some of the basics. Now at the top left here, you'll see that we have the estimated time remaining. I have over 11 hours of time available on the battery. This means that if I were to lose power right now, my battery, based on its current state of charge being 100%, and the home's consumption being around 1,800 watts, is going to last about 11 hours. You'll notice it will fluctuate based on the consumption of the home. Now to the right here, you're going to see another number, 101%. This number right here indicates what my past 24-hour autonomy to the grid has been. This means that between 3:22 today and 3:22 yesterday, I have not used any grid power at all. I have been 100% off grid based on solar and battery storage. So the normal operation of my system is considered self-consumption. This basically, or daily cycling actually can be said as well. This basically means that my system will take solar power, store the battery, actually power the loads in the home first. Any excess solar power then charges the battery, and then any excess power after that will go to the grid. That will only happen after the battery gets to 100%. One last thing on this dashboard you'll notice is the backup reserve. My backup reserve I typically keep around 9%. This means at the end of the day, when solar power goes away, my battery is going to discharge from 100% all the way down to 9% to power the loads in the home. It will typically run until about 12 to 12:30 at night until it gets down to that 9%. There are a few other settings that you can see here about the battery. These are the different operating modes of the battery. I mentioned earlier that my battery, when it was first installed, we used it as strictly backup, and that would be this mode here. I use it in self-consumption, which we talked about. And there's also time of use, which is something that if you have time of use rates, works quite well when using the Sonnen battery. You don't even need solar to accomplish that. You'll see I can set my microgrid recheck times. These work for when your system is sort of offline, if you will, for a long extended period of time. Maybe there's a hurricane or something like that, and you've had a power loss for 3 days. Well, the Sonnen battery's got an intelligent piece to it where it will stay alive, but in a very dormant state. And it'll wake up at these recheck times to see if there's any power available, either from the grid or from solar. And if there is, it'll actually wake its full brain up and start doing what it's supposed to do. You can also, as you can see here, connect a generator to the Sonnen battery and set the automatic start, turn on point, and turn off point. So this would indicate that when the generator, or when the Sonnen battery gets to 8%, that's when we want to go ahead and kick the generator on. And when the Sonnen battery is charged to 94%, we would turn off the generator. The next thing I want to talk to you about is some basic information that the battery provides about a system and the grid and BMS. Real simple information: production, consumption, the capacity of the battery. We talked a little bit about how many modules I have. I've got 10 modules, each one being 2 kilowatt hour. It gives me my 20 kilowatt hour. And then my inverter maximum. And you'll also notice the AC voltage and frequency and DC voltage of both the grid and the battery itself. To the right of that on the dashboard is our usage information. Now, because of our interconnection to Curb, we are able to bring in all of this monitoring data. At the very top, you'll notice that I'm producing a little under 6,000 watts. The home's total consumption is about 4,300, and that means that I'm feeding the grid a little under 1,500 watts. I'm 100% off-grid, and my home is powered from solar. You'll also notice that we separate the production circuits from the consumption circuits. These are the CTs. Each one of these represents a CT that we talked about earlier. Now you'll notice also I have a lot more that I'm monitoring. A lot of things here that are off and a few things that are on. In this view, I can see my top consuming at the top of the list and my top producing at the top of the list. I can also switch over to an alphabetical view if I'm trying to really pinpoint a load, because obviously with this top-down approach, these will shift and change. The next part of the dashboard is the breaker control piece. This is where I can actually turn on and off any one of those 16 relay-controlled breakers. So you can see here that my hot water circulation pump is currently drawing 25 watts. I see that data courtesy of Curb. And if I hit this and turn it off, that just shut down the breaker in the load center, and you can see that we're drawing 0 watts. I'll go ahead and turn that back on, and it will start consuming power, and it'll work its way up to 25 to 30 watts, which is generally where it is. Now, this is all fine and good. We love to be able to see information, control things, but this is about energy automation. And the automation side of it is in our scheduler. This is where you're going to determine what you want to have happen at what time. So simply by opening up a new schedule, I can give this a name, say test 3. I can choose to have a schedule run at an exact time, or maybe at sunrise, which in my case is 7:47 a.m., or at sunset, which is 6:37 p.m. I can even choose an offset to that, so I could say 2 hours after sunset. I can choose the days of the week, so maybe this schedule's only going to run Monday through Friday. I can also set my HVAC temperatures based on this schedule. So I'm going to say I'll set this to 70 degrees and 68, and you can see it changed because we have a deadband built in. We also now can set certain breakers to either turn on or off. And in this case, I'm just going to say, let's turn on hot water heaters 1 and 2, and we'll turn off the EV charger and the pool pump. And last but not least, we can also set a backup reserve. So when this schedule runs, it's going to set my HVAC for me. It's going to change some breakers, turning some on and some off, and it's going to set the backup reserve. And it will also send me a text notification letting me know that Adapt Energy has run test 3 in the schedule. This allows you to manage the energy in the home and have this automated so that you don't have to touch it. And your list will show you all of your schedules, and you can choose to see them all, or you can see just the ones that are going to run today based on how you've set your schedules. In the setup area, this is where you're going to make adjustments to the text notification, so add phone numbers for whomever you would like to be notified of grid loss and weather events and things like your surge protector and schedules. You can also set up your own power profiles. So you can decide what happens when you press these buttons. In my case, I have one labeled Turn Most Circuits On, and most circuits meaning that I'm going to turn off these three and everything else will stay the way it was. And these are totally configurable. Now, there's a deeper level setup that you can go into. This is not typically something a homeowner would ever need to go deal with or do, but I'll show it just so that you can see a little bit of the setup. Giving breaker information here, maybe a description of the breaker. In this case, the solar array can generate up to 3,840 watts. This is where I would adjust my curb monitoring and assign any one of these monitored loads or CTs to a controlled breaker. And this is where we determine what is going to happen during a power event. Now, these power events are things that are out of our control. So like a grid loss. When a grid loss occurs, I leave solar array 1 and 2 on, but I shut down 3 and 4. I do this because I want to make sure that I stay just under that 8,000 watt inverter capacity in the Sonnen battery. I'm also going to leave my east AC condenser and furnace and fan on. However, you can see I've set a delay. This helps with the inrush of power so that when a grid loss occurs, the battery does not get hit with a whole bunch of load. We actually wait a little bit. And we also make sure to turn off the west furnace and fan and west AC condenser. We lock those controls as well so that you cannot turn them on because the battery itself cannot power both the east and west AC condensers. Now when the grid comes back, we do the obvious, at least what I would think would be obvious, we turn everything back on. Now when we detect severe weather, we do a few other things. We don't do much to the load because we haven't lost power yet. However, we do load balance the home. This means I want to shut down some things because I'm also going to tell the battery to charge up to 100%. Now I do this because my normal backup reserve in self-consumption or daily cycling is 9%. But if there's severe weather in the area and I have a higher probability of having a grid loss, I want that battery to be at 100%, so I now have my, roughly 11 hours of capacity. The other thing the system's going to do is pre-cool and preheat the home. This way, if I actually do have a power outage, my home is nice and comfortable, and I won't necessarily have to use battery power to power my air conditioners or my heaters. And last but not least, our weather alerts. As you can see, there are quite a few. You simply need to pick which alerts you want to be notified about. And if you've chosen to include an alert, you will be notified via text. And you can also set it to automatically protect the home. So if auto protect is selected, it is going to run that severe weather sequence that we looked at just a moment ago, and it'll do that automatically. If it is not selected, you will still have the option. So now let's talk a little bit about the customer-facing iPhone application. Now, in the iPhone application, you're going to have a lot of information about what's going on with the battery and the power in the home. As you can see here, you can set your backup reserve. I have my backup reserve set to 9% because I use my system as a daily cycling system. You can see what your solar production is. You can see how much energy storage time you have available. That is relative to the battery's current state of charge and the home's current consumption. Now, my battery being at 100% right now and the home consumption being under 2,000 watts, I'm going to be a little over 11 hours of power available. So if I were to lose grid loss or have a grid loss right now, I'm going to be able to run for a good 11 plus hours. You can also see that I'm generating a little over 5,500 watts of solar, and the home's only using a little under 1,800 watts. So the rest is actually being fed back to the grid. This number here is going to tell you exactly how much you've been autonomous to the grid in a 24-hour period. So between 3:41 today and 3:41 yesterday, I have been 101% autonomous to the grid. This means that I have not used any grid power between 3:41 yesterday and 3:41 today. You have one other thing that you can do. This is your breaker control page. This is where you have the ability to turn on or off breakers as you see fit in different situations. So if we take a look at this hot water circulation pump right here and see it's drawing 25 watts, I'm going to go ahead and turn that off. Now that physically just shut off a breaker in my load center. And you'll also notice that it's drawing 0 watts now. We'll go ahead and turn that back on. And as soon as we start drawing power, you'll see that it will raise back up to whatever it was. Most of the time, you're not going to need to manage this because it's an automated system and it's going to handle all of this for you. However, you may be in a situation where you have a grid loss occur and the system has automatically shut off certain things like pool pumps and hot water heaters, and you may want to go ahead and turn on a hot water heater so that you can take a hot shower.